right, this is a short, quick little one. So we're going to be solving quadratics again. We have already done this with factoring. Okay, 100% did this with factoring already. All right, so we're going to cover it again because it's super important. There are several different methods of solving a quadratic equation. The first one is by graphing. Now, I'm not going to have you physically graph these. I'm going to have you put them in Desmos, and you'll solve it from there. But a solution to a quadratic, or as you go into later maths, a polynomial, okay, is where the graph crosses the x-axis. So a quadratic, first and foremost, is a polynomial. I have to send out with one variable with a degree of 2. Okay, solutions of a polynomial. Okay, this little symbol right here means therefore. Solution to a polynomial, therefore quadratic, where the graph of the function crosses the x-axis. And there are several different names for these. Okay, the main one is that they're x-intercepts. But they're also called zeros, roots, solutions. Okay, so I'm looking for where it crosses the x-axis. All right, so in this graph, y equals x squared plus x minus 2. All right, when we factor, we would set the equation equal to 0. And by doing so, you're physically looking for where the graph crosses the x-axis. I can see on this graph where it crosses the x-axis. So the solutions to that system, the solution to that quadratic, are those numbers. So on this right one, the x-coordinate is 1. On this left one, that's -2. Solutions are x equals -2 and x equals 1. If by chance it asks for it as an x-intercept, then this one would be written as -2, 0, because we set it equal to 0. And the other one would be 1, 0. In this particular graph, -x squared minus 2x, first thing you should notice is that it's upside down because of that negative sign. And we set that equal to 0. Okay, and I set it equal to 0 because you're solving it. And then we see where it crosses the x-axis. So this right side would be 1, or that's a lie. The right side would be 0, and this left side would be -2. So my two solutions, x equals -2, x equals 0. If I wanted them as x-intercepts, as the ordered pair, this one becomes -2, 0, and that one becomes 0, 0. Just kind of depends on the directions. And our last one, 2x squared minus 12x plus 18. This one has a GCF. If you were to take that GCF out, it would have 0 effect on where this graph crosses the x-axis. We're still going to set it equal to 0. And then see where it hits the x-axis. So it only hits once, and that's at 3. If I want it as an x-intercept, 3, 0. All right, in these four, I'm not giving you the graph. So you can put it in Desmos. So you're going to put these graphs in Desmos and see where it hits the x-axis. So example D, x squared, f of x equals x squared minus 4x minus 5. Again, set it equal to 0. Just to get in that habit. And then I type this into Desmos graphing. Okay, now I've already done this. Okay, I don't need the equation part of it. I just need the x squared minus 4x minus 5. And then make sure that equation is selected. And then you can see where it crosses the x-axis. So at -1 and at 5. And if you want them as x-intercepts, 1, 0, 5, 0. And the reason the y-coordinate is a 0 is because we set it equal to 0. All right, -x squared plus 15x minus 56. This graph is upside down because of this negative sign right here. We're still going to set it equal to 0, though. Put it in Desmos, which I have. Make sure your equation is selected. And then we click the little gray dots. So 7 and 8. And again, depending on the directions, if it asks for the x-intercepts, they want it as an ordered pair. All right, f of x equals x squared minus 8x plus 16. Set the equation equal to 0. Put it in Desmos, which I have. Make sure it's selected. Then I can see where it hits the x-axis at 4. And if you want it as an x-intercept, 4, 0. Last one, negative 3x squared plus 9x. Set it equal to 0. Put it in Desmos. Make sure your equation is selected. And we see where it hits the x-axis at 0, 0, and 3, 0. Now, graphing only works and works well if your x-intercepts are whole numbers. If they're not whole numbers, you can get some really psychodecimals here. If they're not whole numbers, then graphing is not my method.